Spacesuits from the pages of Dune and sulfur on Mars. You're listening to Are We There Yet? The radio show exploring space exploration. Hi, I'm Brendan Byrne. In the book Dune, the characters use what's referred to as a still suit to recycle urine into drinking water. And now, scientists are trying to recreate that idea for real. The spacesuits will help astronauts for longer missions, spacewalks, and provide more comfortable suit for the space travelers. We'll speak with Sophia Etlin and Christopher Mason about their resourceful spacesuit design. Then, more signs of life on Mars. While exploring the red planet, Curiosity found a rock containing sulfur, something scientists never imagined would be found on Mars. We'll speak with astrobiologist Amy Williams about Curiosity's new discovery and how it's bringing on more questions about the red planet. That's ahead on Are We There Yet? Where do astronauts go for a spacewalk when they have to go? For now, they use a high-tech diaper, but one group of researchers wants to change that. The idea came from the book Dune, and it aims to recycle that wastewater into potable drinking water and other things, allowing spacewalkers to ditch the diaper. Here to talk about their design and the importance of having a suit that can recycle fluids is Sophia Etlin and Christopher Mason, researchers at Weill Cornell Medicine. Sophia, welcome to the show.
Hi, thank you so much for having me.
Well, thanks for joining us for a really exciting topic here. Oftentimes we see science fiction and science fact, but in this particular case, your research has combined both with this spacesuit that was inspired by the book Dune. For those of us who haven't read it, let's talk about what the still suit is and how you were inspired to create a real life one out of the pages of the book.
Yeah, of course. So Dune takes place many years in the future, and within it, there's this planet called Arrakis that has been turned into this wasteland where there is practically no water available whatsoever. And the Fremen people have to create this still suit that, as they exist in this world, collects their body's wastewater, so urine, sweat, water vapor from breath, recycles it within the suit, and returns it as potable water for them to drink. So this self-sustained, circular economy of water that requires no inputs. I mean, I've been a huge fan of Dune ever since I can remember. And college, I had started prototyping, sort of designing what this could look like.
What is the current technology now? What happens to wastewater like urine now? And where does clean water come from in the current astronaut suits?
The current suits, the Extravehicular Mobility Unit, or EMU, are actually from the 70s. No new spacesuits have been created since the Apollo missions. And so there's only 4 in operation currently, because every other one has been destroyed or is in maintenance. And originally, only men were allowed to be astronauts, right? So the waste management system within spacesuits was actually a condom catheter. And then when women were suddenly allowed to go to space, they scrambled to find a unisex solution, which was what is now the maximum absorbency garment, or a large adult diaper. And it's even glorified to call it a system at all. And this is another issue that astronauts face. Currently, astronauts are given less than a liter of water to drink per spacewalk.
Is that liter of water limited because of just resource allocations within the spacesuit, or is that small amount of water so that they don't urinate too often and have to deal with it? Why is that limit there?
Astronauts actually drink less water than they should coming into spacewalks and during them because, and I quote, and this is in the paper, sometimes I can't tell urine from sweat anymore during these spacewalks. And there is that issue of literal astronaut work performance decreasing due to dehydration. It's also a size issue within the suit of how much water it can actually contain within the IDB when you're not recycling it. And there's also the waste aspect of it. The ISS currently recycles 98% of all of their wastewater. So that's over 6,000 liters a year of urine being recycled within the ISS. And now you're just putting this water in this suit that's being completely wasted onto this diaper slash damaging the suit as it leaks everywhere. And then you get these diapers and put them in these little capsules and shoot them into the atmosphere where it burns up. So like it's so paradoxical that you have this agency, right, that prioritizes sustainability and recycling to the T on the ISS, and then is sending us, shooting stars of adult diapers on the other hand. So
I want to bring in researcher Chris Mason, who's also working on this project. Chris, first of all, welcome to the show. Tell me a bit about your role in developing this prototype and what you're doing to get it moving forward.
Yeah, so Sophia and I started meeting to plan out this project just over a year ago, and we did some of the initial testing up at Cornell, and then did some follow-up work at Weill Cornell in the lab in New York City, in my lab there. And so I'm a geneticist and always been thinking about ways to really improve crew health, ways to monitor them long-term for personalized health and personalized hygiene. And so what's really exciting about this suit is it is a piece of hardware Sophia and I have been developing, and with others in the lab, to improve, as you've heard, how we actually recycle water and improve future missions to the moon and Mars, but also can enable new safety, new technology to be deployed in the suit. And it really links to broader work in our lab. We do work with NASA and SpaceX and Axiom and others to map out astronaut health for everything from the year study with Scott Kelly to shorter flights we just published on the Inspiration 4 mission, where 4 civilians went into space, and they went up for just a few days. But we're really at the beginning of, I think, a new space age where many, many more civilians and, if you will, regular people will be going to space and living and working in space.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Sophia Etlin and Christopher Mason, researchers at Weill Cornell Medicine, about their spacesuit design that will be able to recycle urine into drinkable water for astronauts. Chris, Sophia was telling us a bit about the motivation to create something like this and also how it could potentially help for spacewalks. But as we know, there is a water and urine reclamation system on the International Space Station itself. Does your technology use a similar process to that, or how is it different?
It's related, but has additional components. So some of it is both forward and reverse osmosis, and also is activated a bit based on the humidity. So the filtration system in the ISS is continuously operating, and it's for the whole station, whereas this is, for one person. It has slightly different physical properties. But the goal is the same, is to reclaim that water, really start to make it so people could plan to do these longer walks and use all that water that currently gets lost.
Funnily enough, this system is sort of a very small branch off of what the Mason Lab and other labs like it are trying to do, which is sort of redefining how we look at astronauts, right? Redefining what an astronaut is. So with our process of filtration, after forward osmosis, we're left with urine brine, for example. And there's work being done in the lab about lunar farming, for example. And urine brine can serve as an excellent sort of fertilizer method for lunar farming. And so you're always trying to find these ways of saying, how are we going to make life in any way, shape, or form sort of sustainable there, as well as considering who will be using the system, right? It's one thing for someone, from the Apollo missions who's super tough and it's like, I can wear a diaper, like it doesn't matter, right? I'm here to do X and X and X. But now with these private missions that, we're doing all these studies on and gathering data on, now suddenly someone might have a comorbidity, right? And getting a UTI from the diaper you were wearing during your spacewalk isn't really acceptable. Or you're a space tourist and, you're pushing the industry forward. The first thing you want to put on after all that money you've spent to go to space in the diaper? No, right? Like the whole industry is sort of shifting in the new space age.
Chris, you mentioned something interesting at the start of your conversation here that we're continuing to monitor people in space. I know that there was a lot of monitoring of the Inspiration 4 astronauts and the Axiom private astronauts. Could a system like this also be designed to take kind of a look at the astronauts' health? Are you able to view how they're doing with space travel by taking a look at the urine that's making its way through the system?
Yes, yeah, actually. Then this is something Sophia and I have been chatting a lot about, is ways to make it so you could have, if there's a UTI, you could add in a diagnostic feature. So as the urine is recycled that you could do testing if there's any indication, or even do testing on a daily or even hourly basis. We've flown miniature DNA sequencers into space with Kate Rubins and previous missions. So I know we can even bring genomic technologies into space and do genetic testing for specific viruses, for specific immune functions. And so there's a lot of technology we would long term would like to build into the suit, for sure. And also, when you measure the response, it's the immune system. It could be an infection, but also overall just stress on the body. So it helps you monitor their health. And yeah, we're doing a lot more of this with the upcoming Polaris Dawn mission, upcoming Axiom missions, and some other space agencies. So it's really a great time to get into space and get more hardware into space, because the crews are now really sharing their data, being opened up to new protocols and more modern technologies for biomonitoring.
And finally, let's talk about that process of getting it to space. Sophia, what are the next steps? When could we see this thing fly?
For next steps, getting anything into space takes a lot of time. And when it comes to our system, the filtration aspect of it is easy enough in a sense, because you can test it in the lab, the efficacy in the lab. Is it filtered? Is it not? Does it taste like urine or not? And then there's all sorts of testing that Chris is way more familiar with than I am as of yet. Of you need to detonate the system in order to see if it's harmful, where it should detonate, that sort of thing. But when it comes to the external catheter piece, that requires actual testing on people, right? Because that's what's going to be lying on. So we got IRB approval to do a study on patients coming now in the fall, earlier October, to test out these different external catheters, or the male and the female version of the external catheters, and see about fit and comfort, and does it stay on, sort of thing.
And Chris, is there an opportunity to test this on the ground? Could this be used for other industries that may have an interest in being able to have access to technology like this?
Yeah, definitely. So we think, much like we've been deploying hospital technology for diagnostics into many markets, I think, this kind of filtration could help rural areas in this country or other countries, places where limited resource settings, where you need a way to purify water, not just for drinking, but farming, for other aspects of crops, or just maintaining a house or a city. Even my brother reached out, who's a mayor of a city in Wisconsin, and said, this it could help with, a municipality. We're thinking about new ways to have cheaper and better and more efficient purification methods. So there's water is essential for life as we know it, and so I think it's something to really keep an eye on as ways to make it better, more pure and more usable.
We've been speaking with Sophia Etland and Chris Mason. They are researchers at Weill Cornell who are working on a prototype to design a spacesuit that recycles urine into potable drinking water. Chris, Sophia, thank you so much for joining us.
Pleasure.
Still to come, a curious finding of sulfur by Curiosity on Mars. That's ahead on Are We There Yet? You're listening to Are We There Yet? I'm Brendan Byrne. Sulfur on Mars. It's not something scientists expected to find, but that's the case after NASA's Curiosity rover accidentally cracked open a Martian rock. Sulfur is one of the key building blocks for life to thrive on Earth, and its discovery on Mars is giving scientists new leads in the search for life on another world. Here to talk about the unique finding is Amy Williams, a member of the rover's science team and astrobiologist at the University of Florida. Amy, welcome back to the show.
Thanks so much for having me.
So, a stunning new finding from our Mars rover friend that you always come and talk to us about. What could you possibly be surprised by this time? It seems like every time you're on the show, there's something cool. What else is going on?
Oh, there's always something cool on Mars, but this one is particularly cool for me, and I think for our community, because it's a mineral that we've never seen on Mars before. And I know for a lot of folks, you're like, what even is a mineral? It's a kind of a fundamental component that can make up rocks. And it's really cool to see something that you've never seen before on another world. And this is elemental sulfur. So this is something that we've never been able to, we've just never run across on Mars before. And Curiosity happened to roll over a rock, busted open, and it caught our attention as looking different. And after performing some analyses, we were able to say this is a mineral we know is on Earth, but we've never seen on Mars before.
So wait, the rover ran over the rock and crushed it, and that's how you found it?
Yes. So we think we leave this minor wake of destruction as we roll over things. I mean, it's a heavy rover, even in reduced gravity, and so we actually have used that as a tool, for both missions to roll over rocks and break them open, sometimes on purpose and sometimes on accident. And so, yeah, in this case, this was just one of those fortuitous chances. We just happened to roll across a rock, and we often take imaging once we stop driving at the end of the day and just happen to see it. And so it gave us an opportunity to stop and investigate this unique looking mineralogy. We actually found something new.
We had Dante Loretta on previously, who's the principal investigator of the OSIRIS-REx mission, and he said going through that sample, he spotted something with his eyes that caught him by surprise, and that led to a very intriguing discovery of phosphate from that sample. And now I'm hearing the same thing of Curiosity spotting something. I'm looking at these images here. They are starkly different than the red rock that we're used to seeing, right? So, I mean, this was an issue of you just saw it and you're like, that looks pretty interesting.
Yes. I mean, there is so much of an element of exploration and discovery and a little bit of serendipity that goes into these missions. It's one of the things that I think about, when we're operating these missions is if you don't look with the rover eyes, you're not going to see it. Like that experience is so different from us as humans. We're perceiving our environment around us, and there are some things that maybe even subconsciously you recognize, but you don't have all of those abilities available to you on a rover. So if you don't look at it with the rover eyes, you're going to miss it. And this was just another example where we were lucky enough to look and to see it. And I always wonder about how much have we rolled over and just kept going and missed those opportunities. It's a different way of experiencing reality, working on Mars and having those limitations, but also knowing, we're not quite ready to send humans to Mars. So this is the only way we get to see such cool things on another world. Good
thing you have a set of eyes on Curiosity. What about if Curiosity had a nose? When you say sulfur, I'm thinking of something very, very stinky.
So, we actually have a little bit of a technique on the SAM instrument on Curiosity that we call sniffing. So you can actually sniff the atmosphere and learn about the atmospheric composition. Unfortunately, that kind of sniffing wouldn't give us that characteristic, sort of like rotten egg smell that humans associate with sulfur on Earth. What we could do, though, is you look at these minerals, you can tell it looks different. It's got sort of a yellow sheen to it. And so, we explore the different minerals that we see around us and say, okay, this looks actually like sulfur. And you can use our laser ablation instruments like ChemCam to get this information. And then we start deploying our contact instruments to understand more about what we're looking at. So in this case, although we can't sniff these minerals, these rocks, and be able to tell it's sulfur, we do have this really awesome tool set that we can use to say, this is something we haven't seen before on Mars.
We're going to get into what the impact of the finding of sulfur means in a moment, but now you have intrigued me because you have the sniffer on Curiosity. What does Mars smell like? Can we point out what Mars smells like?
Gosh, I haven't even thought about how you might be able to do that. I mean, we can tell what the atmosphere, it's mostly CO2. Gosh, I don't even know how we might describe what it smells like. Because we have, obviously we have all these beautiful images. We have microphones on Perseverance. So we've actually recorded the sound of wind blowing across the Martian surface, which is just this incredible ethereal noise. So let's see, we can see, we can hear, we can sniff. I don't know how we might describe that smell. I don't know what Mars might taste like. I don't know that we quite have that capability yet. But yeah, you're absolutely right. We can apply all of these really cool tools to sort of having almost a human experience of what it's like to be on Mars. But I have to go back now and poke at some friends and ask if they have an idea of what Mars might smell like.
I love that. And maybe we can get some smell-o-vision tech on the next rover.
Absolutely. I feel like instrument maturation really should turn towards smell-o-vision.
Well, in this particular case, this sulfur is not the stinky, rotten egg sulfur you found. So once we do get that smell-o-vision, it'll be pleasant, we assume. But what does this finding mean? You said that this is surprising. It's something that you've never seen on another planet before. So what can you as a scientist infer about why it's there and what it means?
So as a geologist, one of the really cool things that I'm able to do is look at an environment, look at the way the rocks have been formed or deposited, and that gets down even to individual minerals. And that tells us about the environments in which they formed. Now, elemental sulfur is often encountered in like fumarolic or volcanic environments, places where you have these gases coming up from volcanic environments, and it precipitates this yellow elemental sulfur. And so that's where you normally expect to see something like this. And what is even more intriguing beyond detecting, a brand new rock mineral that we've never seen on Mars before is that this is not it's not near a volcanic vent. There's no evident volcanism nearby. And so the environment doesn't match our initial expectations. So this is yet again another really lovely example of Mars throwing a curveball at us. So now what we get to do is try to figure out, okay, what other reactions, geochemical reactions could generate sulfur in this environment where we're actually in basically a big channel that's been cut by water, billions of years ago. So we're still trying to understand why this deposit is where it is on Mars. And we know we're in a sulfur-rich area, but it's mostly in the form of these salts called sulfates that formed as Mars, or at least Gale Crater, was drying out. So this elemental sulfur is in a different form, and it's just not what you expect for the environment. So we have quite a bit more investigation to do to try to reconcile why would you see this deposit here, and what can it tell us about the conditions that Gale Crater and Mount Sharp experienced billions of years ago.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Amy Williams, a member of the rover's science teams and astrobiologist at the University of Florida, about the Curiosity rover's curious discovery of sulfur on Mars. Could it help you answer questions as to whether or not the environment could be habitable? Is this a particular element that is conducive to life or evidence of life?
Yeah, so sulfur is one of the kind of major elements that we know life as we know it requires: is carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. So yes, having elemental sulfur around tells us so much more about how sulfur may be cycling in the Martian environment in the past or even today. And so that kind of sulfur availability, it can tell us a bit about habitability, whether life in the past could have utilized that element. So yeah, there are so many avenues that we're now starting to explore with this new discovery. It allows us to kind of broaden what we might define as a habitable environment.
You said it's another instance of Mars throwing you a curveball. Does this change what Curiosity is going to be up to in the short term or maybe even the long term?
I think that this falls into the category of these neat little finds. So things that you don't expect. You're not in the environment where you think you would see something like this. It's just sort of a surprise and a welcome surprise. I think that it's going to help us continue to understand and have this evolving understanding of what the sulfate unit is at Mount Sharp and Gale Crater, with the different varieties of sulfur that are there. And it tells us more about what Mars was experiencing as it was drying out and becoming this cold, dry desert that we know today. We're going to continue kind of climbing up this channel that was carved by water and continue exploring, but it gives us one more thing to keep our eyes open for. These kind of almost random chance discoveries that broaden and deepen our understanding of Mars.
And I think it's important to note, Amy, that we're talking about a finding from Curiosity, which landed, if I'm not mistaken, in 2012. So this vehicle has been doing observations for 12 years now. I mean, you're still getting so much interesting data from a robot that's more than a decade old. Will Curiosity continue to be finding this stuff? Is there an end in sight for Curiosity, or is retirement very, very far on the Mars horizon for it?
I truly hope it is far, far on the Mars horizon. I mean, this is, I think, just one more demonstration of how even a mission that's more than a decade old is giving us new insights, new data, keeping us on our toes. Curiosity uses an RTG as an energy source, as does Perseverance. So they're not limited by solar power and solar panels. So my deep hope is that we have quite a bit more time before retirement for Curiosity. She's been a really incredible mission, and it's just so elevating. It's just so positive for me to think about all these cool discoveries we're still getting, like you said, 12 years into this mission.
And just so we don't get any mean tweets from our friend Percy, what is Perseverance up to? We spent the whole segment talking about Curiosity, but what's on the horizon for Perseverance, and what are you most excited for in the future?
Oh, so Perseverance is right at the margin between Jezero crater and sort of the crater rim and the ancient terrain around it. We've been exploring this really cool area that's sort of this light-toned unit that we've seen from orbit for decades as we've been kind of planning, deciding to come to Jezero. And it's called Bright Angel, which is a really fun name since it's this really bright, light-toned rock that we see from orbit. And so we're currently exploring sort of this light-toned deposit in another channel that was carved by water and trying to understand how it was formed, what the margin unit is, how it formed, what kind of habitable environments may have been present there. And of course, we're always searching for those rocks that might contain evidence for ancient life. And so we're in this really unique area. We really haven't seen anything like this until we got into this margin unit and been able to explore it. So we're still having a lot of fun exploring that region on our way out of the crater and into the really ancient Nowakian terrain. So all love to Perseverance and our mission there as well. She's carrying on as well, doing really incredible science.
Well, here's to hoping that those rovers accidentally run over some more rocks and you can make some more surprising findings. So
you never know when it's coming. Yep.
We've been speaking with Amy Williams. She's an astrobiologist at the University of Florida, member of the science team for the Mars rovers. Amy, thank you so much for bringing us up to speed on what's happening on the Red Planet.
Of course, and thank you.
That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. Stay connected with this show. Be sure to follow us on social media. Find us on Instagram and Facebook. We're at AWTY Space. And if you got an idea for a future episode of the show, or you want to join us as a guest, reach out to us. Our email is awty@cfpublic.org. We've got more space coverage online. Visit cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our producer is Marion Summerall. Our intern is Sophie Diaz. Editorial guidance from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.